I'm Grant Hocking with GeoSierra.
In this brief video, we'll describe GeoSierra's carbon energy storage scheme in legacy oil and gas fields. You have a depleted gas reservoir overlying a depleted oil reservoir. GeoSierra's Azi-Frac technology can install multiple vertical sand planes in both reservoirs. So carbon dioxide is captured from power plants and is actually injected into both reservoirs, the gas and oil reservoir. But it's held at a low energy state, primarily in the gas reservoir. When there's excess energy around, the carbon dioxide is pumped to a high energy state into the oil reservoir. And when there's a peak demand for electricity, the carbon dioxide is released into the gas reservoir, driving a turbine generating electricity for peak demand. So it's like a big, very large battery. However, it isn't just a battery, it also has three objectives. It's a closed cycle system, so there's no emissions. But first, it's carbon storage in a geological environment. Two, it's an oil producer because the depleted oil reservoir, there is a large amount of oil that can be taken out of there by gravity drainage and miscible displacement of the carbon dioxide. And finally, energy storage. It is a cheap, very large scale energy storage, which is exactly what's required for renewables. Most renewable energy systems like wave, wind, solar, and tidal are intermittent producers. So the biggest challenge for renewables is have a cheap energy storage scheme, and that's what this scheme is all about. GeoSierra's carbon energy storage scheme used legacy oil and gas reservoirs. The gas reservoir overlies the oil reservoir, and both have cap rocks that have geologically contained them over millennia. Both reservoirs are ductile, and GeoSierra's Azi-Frac technology can install vertical sand planes on multiple azimuths in both reservoirs. This allows carbon dioxide to be extracted from one reservoir and injected into the other in a closed cycle mode. So the benefits of this scheme are threefold. One, geological storage of carbon dioxide. Two, the permeable planes enable gravity drainage of the depleted oil reservoir. Even though the oil reservoir has been depleted, that has had recovery of approximately 35%, there's still a large amount of oil in place. By gravity drainage, we can recover 75 to 80% of the original oil in place. And with the carbon dioxide at supercritical conditions, it's miscible with the oil and reduces its viscosity. So that's the second point. We end up being an oil producer, and we can produce as much oil as there has been initially. And thirdly, and most importantly, is the energy storage component. The carbon dioxide is cycled when there's no demand for energy and the renewables are producing at their maximum. The energy from the renewables powers a pump that pumps the carbon dioxide from the gas reservoir at low pressure down to the deep oil reservoir at high pressure. This is stored until peak demand is required, and then at peak demand, the carbon dioxide is released from the deep reservoir at high pressure, drives a turbine, producing electricity for peak demand, and the carbon dioxide is stored at low pressure in the gas reservoir. And this is repeated over and over. It's a very efficient system. It's closed cycle, so there's no emissions.